so now let's take a look at the same problem, problem number 24. We'll look at it from the perspective of a one-tailed test. So this problem wasn't really written for one-tailed, so we'll have to apply our own logic to make it a one-tailed problem here. So step one with our hypotheses, the alternate hypothesis is, and we're going to be comparing treated populations mean 1 and 2 again, and the null hypothesis, is going to start, of course, the same way. And then before we either said did or did not equal 0. So just like we've seen in other chapters, we're going to erase the equal and does not equal signs and replace those with less than and or greater than or equal to signs. So let's think about it. They're asking the samples to estimate the speed at which cars were traveling. And the idea is that if the sample is asked how fast were the cars going when they smashed, that those people would tend to give a higher estimate of speed than folks that heard the question as how fast were they going when they hit each other. So the first sample is the smashed sample. So that's representing this first population. So these folks are getting told smashed and these folks are getting told hit. Well, these folks should have an estimate that's higher in speed, higher in miles per hour than these folks. So a higher number minus a lower number, right? Just think of it as, again, when in doubt, just plug in simple little example numbers to think through. If we think about this as 10 minus 5, well, what is the answer to that is 5. So that answer is going to be greater than 0. The first sample scores should be greater than the second sample scores. The other way to think about it is they said that the treatment would cause scores to increase. The treatment is being told smashed. So, but I find it safer for this chapter to think about it in terms of very specific, this sample compared to that sample, which one's supposed to score higher. Again, if we thought the hit group, if we thought with our language that hit sounded faster than smashed, we would say, oh, well, this number should be lower than that number, and we would get a -5 on that. Oh, that's less than 0. So we would just flip the sign around to a less than. So you just have to stop and think about it. Which group is which one's supposed to score higher. So that obviously means that down here, we're just going to do what we always do, flip it around backwards so it's less than or equal to 0. So that is our step one. That is our alternate hypothesis. So that's the change we make there. Very similar to other changes. We just have to stop and think about it a little bit, a little bit more than other chapters anyway, to figure out which way that sign goes. Next up is step 2, determining our critical T's. Well, it's now a one-tailed test. We'll keep the alpha level at 0.05. And our degrees of freedom is the same. It's still 15 people in one group and 15 people in another group. So 14 plus 14 gives us a 28. So that didn't change. None of that changed in terms of the alpha or the degrees of freedom. But of course, our 5% instead of getting split in half now is all together in one side. So our critical T is going to change. Now, we're only looking to the right. Right? Remember, look back at your hypothesis test. That symbol for the alternate hypothesis is an arrow, and it's pointing that way. So we're only looking for a positive value here. So make sure you're using the top row of the critical T for the one-tailed test. Then go over to 0.05, find your degrees of freedom, and you should find that your critical T equals positive 1.701. So that is our critical region for this version of this question. Step 3, as we know, doesn't change. Just because we've changed our prediction about the data doesn't mean we've changed the data. So we don't actually have to recompute anything here. The values are all the same as the first side. So our pooled variance is still 33 points. Our estimated standard error is still 2.10 points, which leaves our t statistic still at 2.81. Well, 2.81 is up here, so we can see that we hit the target. So our decision for step 4, I'm just going to write it over here. We are still going to reject the null. And so ultimately this part gets written exactly the same as we did in the two-tailed version of the problem for the APA, because the decision didn't change. So that is the one-tailed version of this test. So really just that step 1 is really the only semi-tricky part of, in a sense, the whole chapter for a lot of the, in terms of the logic of it, at least from my perspective. So that is our independent measures t-test, both two-tailed version and one-tailed version. So we're only going to have one more video segment for this chapter, and we're going to review the mantras, and we're going to talk about the assumptions. We're going to have 3 assumptions for these tests.